Good morning, everybody. Welcome, welcome. Today is Hump Day, Wednesday, February 21st. It is 10 a.m. Central. I say good morning because even you East Coasters, we got you right in, right before lunch. So we're excited that everybody's here. We have almost 100 people on the PODSCast today. So we're super stoked that you guys are all here and joining us today and going to be talking about some really great stuff. So in this webinar, we're going to be talking about the capabilities of the PODS 703 data model, including improvements from previous versions. We're going to talk about strategies for efficient implementation of APR within the PODS framework, and we're going to be talking about the integration process of PODS 703, enabling a more comprehensive and connected approach to the utility infrastructure management. So this has by far been our most popular version of PODS. We're really excited that everybody's here today, and we're super grateful that Jeff is joining us today to walk us through all this stuff. So before we jump into it though, I'm gonna go through a couple of housekeeping items to make sure that everybody knows what's going on here and how to participate. We really like these podcasts to be a two-way participation and interactive as well. So we want to make sure that you understand that you can add your questions to the questions box or to the chat box. And we're going to get to those as we can if time allows, and if not, then we're going to go ahead and list all of those questions, and we're going to get some answers to those and send those out after the podcast. So quick safety moment. February is Heart Month, and so we want to make sure that all of our PODS community is being heart healthy and doing the best that they can to exercise and eat a healthy diet and maintain a healthy weight. You know, it's harder than it seems, right? I actually just got a little recumbent pedal bike thing for under my desk, and believe it or not, it's not just gathering dust. It's not just a footstool for me. I'm actually using it. So any little bit that you can is going to be helpful to you and your health. We want everybody to be around for a really long time. So also, I wanted to say that, you know, we're super excited to have Esri sponsoring this podcast. I say sponsoring. They're, you know, the thought leadership right behind this podcast and giving us some really great information. So Esri has been a principal partner of PODS for a very long time, and we're super grateful for all that they do. In fact, before the podcast started, Jeff and I were talking about what we're going to be doing for the fall forum and getting excited about the spring forum. So I want to make sure that everybody's got their calendars marked for that. And then finally, we're also going to be doing some polling questions. So please make sure that you put that quick poll blue box when it comes up into your primary monitor. Sometimes it doesn't work if you put it into your secondary or tertiary monitor. So next up, real quick about PODS. We actually just got to our 38th country now, Latvia. Welcome to those guys, and we're super excited to have you into the PODS community. PODS celebrated their 25th anniversary last year. You can see my shirt. If you don't have the PODS 25th anniversary tie-dye, we still have a few of them left, so hit me up if you want one. Above and beyond, we're a community, right? A community of thought leadership and innovative people that get together and work diligently towards data management and data governance related to all of that extremely critical information that we need to manage for pipelines, right? So PODS was started as by pipeline operators, and the data model was built for and by pipeline operators. So it's really a great starting point for getting all of your data organized and into a system that not only helps you with compliance, right, but also helps you with many other different attributes such as, you know, business case analysis, risk, you know, project prioritization, and all of those wonderful things that you need to do on a regular basis as a pipeline operator. So the PODS data model is an open Esri compatible platform. It's based in linear referenced. We got quite a few questions before the podcast started about now with utility network is it going to be in lieu of linear referencing? No, the answer is no. It's going to supplement and or you know, build upon that linear referencing. It's just going to add another layer of networking, which Jeff's going to get into. So we're really excited about expanding and building upon the model. I'm not sure whether or not if you all know as well that this PODS 7 model has a lot of flexibility in it. So if you don't want to move all of your data from UPDM into PODS, you don't have to, right? But if you want to utilize something in the PODS 7 model, like the ILI data tables, and connect it to UPDM, you can do that. Of course, do not ask me how to do that. You'll have to ask smart people like Jeff how to do that. So with that, before we get into introductions, I wanted to go ahead and learn a little bit more about you guys. So we're going to launch our first poll on into your quick poll so that we can learn a little bit more about you and who's on the call. So, you know, we get just such a wide array of people within the PODS community. You know, we have engineers, we have people from operations, we have you know, people that are not just in the GIS and IT space, right? There's a lot of integrity management professionals that participate in PODS and the PODS community as well. You know, the PODS data model is the baseline for the MPMS system. So if you have your data in PODS, right, then it's going to help you be much more compliant with those PHMSA regulations. So we have 81% of you that have voted, sorry, 85% now that have voted. So I'm going to close the poll, and we're probably going to be able to guess what those results are. Jeff, what do you think?
All right. We got the operations guys showed up. That's great.
Yeah, we got a couple operations guys. So, and we have just over 100. So we literally have 2 operations guys on the call. So welcome, glad to have you here. So we're going to do another poll real quick because we don't want to interrupt Jeff in his presentation, as well as a live demo, y'all. Come on. I mean, you got to be a little bit genius and a little bit crazy to do a live demo on a podcast, but that it really just speaks to, you know, the usability and how well the product works whenever somebody can do a live demonstration online and for the record, right? So on this one, what are your goals for attending this webinar? You know, are you looking for more education? Are you looking for budget preparation? A lot of companies, and Jeff will probably talk to this as well, a lot of companies are moving to PODS 7 from PODS 5 and 6, but also from PODS 4, right? So there's a lot involved in that and different migrations and budget preparation for sure. So we have 80% have voted. And, oh, Jeff, you're going to be super excited about how everybody voted on this one. I'm going to close the poll and share the results. Sure. Look at that.
Awesome.
Yay, you're in the right place. This is you're going to learn a lot today. And you're going to learn a lot no matter where you are in your journey, right? We talked about that. Jeff's really good about making sure that you know, if this is the first time you've been introduced to it, all the way through to where if you've been working with the crew for a couple years on developing this, there's gonna be takeaways for everybody. So we'll do one more poll, and then I promise we'll get into all the good stuff. This is just mainly for us so that we can know a little bit more about where everybody's at in their journey with PODS and what PODS data model you currently have deployed. Now, of course, you know, it may be PODS 4, but it may be like a version that you deployed 15 years ago, so it possibly doesn't even remotely look like PODS 4 anymore, right? Because you've done so many iterations and changes to it. But it's always good for us to know so that we can give our community what they're looking for. So if you can't vote on where you are right now, I put other in there because in case those operations guys aren't sure what version of PODS they're on, they can throw that in there. Or if you have a homegrown version, right, of some data model that you've created internally, that would be other as well. Or if you're using UPDM, that would be other as well. So we are at 70% voted, so we'll close the poll and share those results there. And not at all surprising, right? Oh, Jeff, look at that. It's the first time that other has the majority of the answer.
There you go. Interesting.
That's pretty cool. It means people are building their own stuff. That's awesome.
Either that or we forgot one of the ones up top.
Oh yeah. Maybe you're on an earlier version. Maybe you're on PODS 2.
I think we've got them all covered. So.
Yeah. Okay, awesome. So before I hand it off to Jeff to talk a little bit more about what he does at Esri and the topic of the day today, I just wanted to real quick give you guys a quick look at the year this year, right? We got a lot of stuff going on. Jeff and I think, are going to get up our level in mileage in our United points, right?
100%.
No, you're Dallas, so you're not. Yeah. So coming up next is going to be a PODS happy hour that's going to be on leap day of the leap year here in Houston. So we had to take advantage of that. So you guys come out to that if you can. We're going to do another PODSCast next month with YPP. That's going to be awesome. And then, of course, we have a lot of stuff going on. Please make sure that you are registered for the PODS Spring Forum and URGIS, right? So that's the same week. The Spring Forum is going to be on the Tuesday, and then URGIS is Wednesday and Thursday. We have a room block on the PODS website for the embassy that has a discounted rate for the whole week. So if you come in for the forum and for URGIS, you can take advantage of that room block for the whole time. So I know, Jeff, you guys have a jam-packed schedule, and I think you're going to be releasing that agenda here coming up pretty soon, right?
Yep, absolutely. We've got a full pipeline track. We had more papers than we ever had received before, so getting ready to finalize that and publish that probably this week.
Awesome. So if you don't already have your ticket to URGIS, please do so. I think you guys still have a couple of booth spots left available too, if people want to exhibit.
We do.
Okay.
We have some booth spots left. That'll be closing on March 1st, and early bird registration is currently going on as well. So save yourself a couple $100 to get registered early. That'll be closing March 1st as well. So.
Awesome. And PODS has a booth too. So you guys come by and check us out at the PODS booth too. So, all right, enough housekeeping stuff. Let's get to the reason why people showed up today. So Jeff, I'm going to hand off control to you, and let's see, did that work? Here we go. There we go. Awesome. And again, Jeff, if you could just give us a quick intro. Everybody knows who you are. Give us a quick intro on you, and then we'll rock and roll. And I'm going to get off camera. So thank you very much again for joining us for this podcast. We really appreciate everything that you do as a board member and Esri as well. So thanks.
Of course. Thanks, everybody. Thanks, everybody, for joining in this morning. Again, my name is Jeff Allen. I'm the pipeline practice lead here at Esri. Been involved with PODS 20 plus years now, various roles, technical committees, board of directors, seen quite a lot and been around the organization. And obviously Esri is a big proponent of PODS and a big supporter of the organization as well. And so what I want to talk about today is this integration of PODS, or the integration of some of this new capability from Esri into the PODS data model. And so although the tool itself is called the utility network, kind of think of it as connected pipes, right? We're adding that new functionality to the model. So we've been traditionally in PODS using linear referencing tools forever. And we have a whole set of tools in the Esri stack called APR that does the linear referencing part. This adds the ability to do these kind of connected pipes or non-station pipes in the model as well. It's meant to work together. It's not an if-or situation. It can be combined with linear referencing. And so that's what I wanted to take you through today. And I really tried to sort of set this up in a way that if you were new to this, or this is some of the first times you've seen one of these webinars, we didn't dive right into the bits and bytes. We kind of give you a little bit of overview of why we're doing this. And for those of you who have been in Brown PODS for years, we'll get into some of the details of exactly what's in this version of the model. But I want to bring up this slide first because it does center me on all the things that we kind of focus on in pipeline data management and pipeline GIS. But one of those key trends still is accurate, complete data that we can share with the rest of the organization. It tends to be very foundational. If we have that, then we can do collaboration. If we're collaborating with non-GIS professional, we can do analytics. We have tools to support the two operations guys that are on the call today. And then we start talking about digital twins as well as part of those trends that we're seeing across the pipeline space. But really, I'm going to focus on these kind of two core data management tools, right? ArcGIS pipeline referencing, which does all the linear referencing piece of the puzzle, and then this new tool, utility network, and the support we've added to PODS to be able to use this tool, this Esri tool as well, with the core data model. And the important part of that is, once we start modeling both station, gathering, pipes in 3D with linear referencing, right? All that starts to become a foundation for what we would consider a digital twin from Esri. And we have a whole different presentation we can go through at some point if you're interested. If you're having a lot of people come into your shop and talk to you about digital twins, don't forget that the ArcGIS platform is actually been doing digital twins forever. And this foundational pipeline data management builds on that capability. But really, one of the things that we see in a continuing demand we see on these systems is this ability to add more and more data. Right? If you think about why these systems were originally put in place, a lot of companies were just doing a digital transformation, getting off of paper maps, paper alignment sheets, putting things in a GIS database or a tabular database, and turning right around and producing alignment sheets from that. Right? But we saw the value of this data within the organization, especially around risk, integrity, and compliance. And we started to pour more and more data into these models. And as we increase the scope and complexity of the objects in the model, we really need to have more complex tools and modeling so we can take advantage of that data. And this is what this is all about. Now, how do we put more in the model? How do we manage more data? In a sense, do it with the same amount of people we've always had. That's the other limiting factor here is, we're not gonna, I don't see pipeline companies going out and hiring, 50 more editors to do this. We just need to have smarter workflows, smarter tools, and smarter processes. But regardless of where you are in your journey, these are some core things that we continue to hear from the pipeline industry. Obviously, the top three are common across everybody. This idea of complete and accurate data, supporting field operations, and sharing across the organization is a foundational component we see in almost every pipeline operator. We also want to integrate this data with operational views like SCADA, right? To provide, people say, hey, can you help me bring these maps alive? A lot of work right now integrating GIS and the pipeline data management databases with other systems, SAP, Maximo, Oracle Financials come to top of mind. And this other idea, this is central to the team today, this one GIS system of record, right? So where we're seeing is companies have had to create, depending on their kind of assets, they're managing multiple GIS systems, multiple tools, multiple databases, multiple versions of those databases, all layering on the complexity of the IT organization to keep all that up and running, right? So companies are saying, hey, we need a one set of reporting tools. We need one set of integrity tools. How can we consolidate these different data models that we've created or acquired into a single system of record that works across the organization? And the other big one we hear, of course, is this idea of these workflows. Nothing happens in an hour. Everything takes a day or a week to complete. And we want to make sure that all the stakeholders that are impacted by some change to the data either do their part of the project or get some type of alert that something's happened, right? And those happen through workflows that span these long transactions that we tend to do in pipelines. Now, if we drop a level below that and talk to the IT folks that are managing these GIS systems, like what are they trying to accomplish? with these new tools and these new technologies. This idea of a simplified architecture, a lot of things that we're showing today, we've been able to do for years and even been able to do on PODS Relational, but it took a lot of glue to stitch all those tools together. And what we find is that as time goes on, people leave the organization, it's really hard to keep these systems maintained. So companies are looking to simplify their architecture so they can do more for the organization with the same amount of resources they have, right? They want to be able to extend it easily. They want it to be a spatial model. They want it to keep current with Esri technology. They want to be able to leverage all our mobility and web tools easily. They want it to be stable when they grow, right? This idea that we have to go through a long regression testing to upgrade things. We want to try to eliminate that or reduce that as much as possible. They want integration options. How do we tie these systems together? And of course, they're also looking for these workflows as well. And then finally, if we get down to the last level, which is the data management folks, these are the people with fingers on the keyboards trying to maintain and build these data models, right? What are the core kind of tools they're looking for? Well, this idea of managing both stationed and non-stationed pipe is critical, right? And as we start to pour more and more data, not everything has a route and measures and equations and hierarchy to it. Some things are just like lines and polygons. How do we manage that within the comprehensive view of the GIS? They want core linear referencing support in Esri. They want to have more intelligent equipment in the model. They want to have business rules. They want true spatial representations. They want to be able to expand the core as needed as regulatory changes or business changes. And they want to be able to do that extension themselves. So those are kind of some of our guiding principles as we design some of these tools. And the other part of this is when we design them, we want to make sure that we could cover that complete supply chain, right? So traditionally, PODS has lived in that midstream space, right? We've done linear referencing on large diameter gas and hazardous liquid transmission pipelines. You very rarely see PODS in distribution, if ever. And we've seen a mixture of success stories in the upstream gathering space. But again, a lot of that time, a lot of those pipes, we're creating more data than we have, right? We're creating routes and measures, but they don't really exist just to try to fit that in the model. So when we set up this idea, we wanted to be able to model the complete supply chain from the wellhead to the meter tip, everything in between, with a single PODS data model, right? That was the goal. And so how did we do that? Well, if we want to model everything in between and we want to put it in a single database, we really need two editing tools that work together to be able to do that. So this POD 703 sits down below pipeline referencing, the linear referencing tools, and the utility network, how we connect pipes together to be able to see all that information in one place. That's the idea here. So it's not just linear referencing, or it's not just utility network. It's just two tools meant to work together inside that data model. And so the other key part of this too is what's driving a lot of this adoption for change is, we're kind of focusing on our GIS professionals again, right? We put a lot of energy into mobility and non-GIS professionals, but we are getting folks now all moved off of the old ArcMap onto Pro, right? So if you remember, ArcMap used to be 3 different products. It was the ArcMap itself, it was our catalog, and ArcGIS Scene for the 3D stuff. ArcGIS Pro is our GIS professional thick client tool going forward. It combines all those capabilities into a single product. It's 64-bit. With all we're moving ArcMap into long-term support on March 1st. And that's got a lot of people saying, hey, we really need to accelerate and move our editors over to ArcGIS Pro. And as you move to Pro, things like APR and utility network can become an option for you for editing pipe data in ArcGIS Pro. Now, the other big change to remember here is we are sort of moving from a different architecture. So in the ArcMap era, we would have a desktop and it would be connected directly to that enterprise geodatabase, right? Traditional versioning, You would make direct connections to the data model, and you would use either out-of-the-box ArcMap tools, or you use more likely a partner application to edit that PODS database. And then we'd take that data, we'd spatialize it if it was in a relational model. If it was in PODS 5 or 6, it was already a spatial model. We'd put that over to the portal in ArcGIS server, and then we'd serve that out to the rest of the organization. But the new paradigm going forward, and this is across all of Esri, this isn't just specifically for the pipeline tools, but the pipeline tools were one of the first to take advantage of it, is that we take that data in the enterprise geodatabase, we publish it to the server, and we edit that data through those REST services. So regardless if I'm in a partner application, or I'm in a web tool, or I'm in ArcGIS Pro, I'm editing directly against the servers coming from the server. And this is important because the server now plays a much larger role. That's where the rules are going to go. That's where the validation of all this linear referencing is going to go. So instead of having to build that type of functionality in each of these different environments, we can just start pulling that data and that capability directly from the server itself. So as you start investigating on this, just know there's a bit of a change to the architecture as you move forward as well. And that becomes very important if you kind of take a step back, because instead of directly having all these partner applications, field applications hitting the database directly, it's really using the power of the services-based architecture. So regardless of the client tier, and this is where the integration with third-party systems comes into play, regardless of who's trying to get at that connected pipe data or linear referencing data, they're going through the same pipes, and we can secure those so we know exactly who has what access to what data. And we do centralize the rules so that everybody's playing off the same sheet of music. So let's unpack the model a little bit now. So this is where I think this slide, I think, really kind of sums it up for me. PODS is the whole thing. Inside of PODS, there are two what I call information models. These are not pipeline data models. These are just the core tables and columns and feature classes that we need to turn on linear referencing capability, routes and events, or turn on connected pipe capability with rules and tiers. So what we've done is we've taken these two core information models and we've worked them back into POD 7. The first one was the APR core schema. We put that in POD 7.0, and it's been there ever since. So if you are a linear referencing only shop, starting at POD 7, you can directly take ArcGIS pipeline referencing tools and point them to that data model and configure it to work because it contains the APR schema. Starting at POD 7.03, we've now put the UN schema in there as well, right? So the utility network, the ability to model connected pipes, has a core set of tables and feature classes and columns that we require that you will now find in PODS 7.03. When you take this tool, this utility network tool, and you point it to POD 7.03, it will work. So how do we tie these two models together? Well, these are on the left-hand side are the core information objects for utility network: devices, junctions, pipelines, assemblies. And in pipeline referencing, if you've ever looked at that information model, you know we have things like calibration points and center lines and routes. When we integrate them together, the pipeline from the utility network becomes the center line for the linear referencing system. So in a sense, that center line feature class goes away. And what we do is we draw pipes everywhere along the main line, gathering, inside the fence. And where we need route and measures, we drop those routes on top of those pipes. So pipes aren't a linear reference object anymore. They now drop down into the utility network because they are connected everywhere. Now, because we need intelligence down there, we also have things like junctions and devices. Devices are things that control the flow. Junctions are things that connect the pipes together. Everything else is in the linear referencing system. Class, HCA, ILI, casing, coding, test pressures, all that stuff still stays as linear referencing objects. We're just really thinking this anything you can go in the field, the steel, right? The steel characteristics, we're going to put those in the utility network. We're going to let those live together, and then we're going to drop all the linear referencing objects on top. So when you unpack this utility network feature class, this information model, it's really just a couple of different things. The first thing is what we call a domain. So now we have a PODS, liquid, and gas pipeline domain network. And the reason this is important is because if you have other types of assets, electric, wastewater, fiber, you can pull those other utility network models and combine it with the PODS model. So PODS has got its own kind of domain network that lives together, but it can live with others. And if we open up that PODS domain network, you see those 5 feature classes that are really at the core. Devices, things that control the flow, lines, the pipelines themselves, the junctions, how they come together, assemblies, which I'll talk about, which are collections of objects, and a thing called a subnetwork. And we'll talk a little bit about the end of the subnetwork. The subnetwork is basically like a built-in hierarchy for you, and it's actually controlled by those devices. So a pressure system would be started by a pump or compressor. Isolation system might be started by a mainline valve, right? So we control and have functionality to let you create a bit of a hierarchy from your devices. Now, when you open up those feature classes, there's a couple of required fields, and you'll find them in POD 7.0.3. Everything has a GUID. We have 2 key columns we call the asset group and asset type. So if you look at the model, you go, Jeff, how can you take all the stuff we have in PODS and boil the ocean down to 5 feature classes for the core attributes? This is where this asset group and asset type comes into play, and I'll explain that in a minute. We have things like association status, how things are connected together, and then we have our typical editor tracking fields that you'd find in most geodatabases. Who created the object, who last updated the object. Anything else that's in those tables was added by PODS. It's business attributes. These are the things that we really key on from a functionality point of view. The devices, lines, and junctions also have other options like, are they connected, what these subnetworks look like, where their tier is, and terminals that I'll talk about. These are all kind of fields that we've added to the model to enable different functionality in the utility network. So here's a great example. Right, we have an asset group, maybe it's a meter, and an asset type, maybe a customer meter, a utility meter, transfer meter, right? So everything in the model has an asset group and an asset type associated with it. And so PODS has basically started to build out not only the functionality or the structure, but the rules that go into that as well. Because now that I've defined what types of objects can go in the utility network, I can start to define how those objects relate to each other. So we used to have just an empty structure, but when you download this PODS 4.03, you'll see that we've actually created these domains and we've created a bunch of rules to get you started. So the rules are just accessed through the enterprise geodatabase, right? They are stored in that enterprise geodatabase. If you right click on the utility network in the toolbar and you look at the rules, you can see all the different types of rules that can be configured. And there's sort of 5 basic types. Junction to junction, how 2 points can interact together. Junction to edge, how the junctions can connect to the pipes themselves. Edge, junction edge, right? What are the rules that 2 pipes can be connected to? Do they need to have a junction in the middle? Can a 10-inch pipe be connected to a 12-inch pipe? No, it needs to have a reducer in the middle, right? There's a business rule. Geographically, they can be connected with a point and 2 lines, but here we're starting to find business rules that go around it. Then we've got containment rules, what things can be contained in other things. And then we have things called structural attachments. These are things that can be connected to the pipeline, but might not hold pressure. CP devices, anchors, river weights, those are kind of attachments that can be a reference to the pipeline, but not necessarily are kind of pressure containment devices. And you can look at these rules. This is an example of this, the screen that comes up for the junction rules. Like I said, we supply you with a whole sort of template data set, and then you can actually modify these rules. You can export them, you can change them, and you can update them as you go. So nothing here that's hidden or predetermined, but we give you a starting point to get started. So what do some of these rules look like? Like, okay, here's an example of a T. This T can be connected to a transmission pipeline, and we have rules around how that might happen. So this is an edge point junction rule. Now here we have sort of connected associations of connectivity. So here I might not have the pipes inside the facility, but I have to have a fitting at the end of my gathering line, and then maybe I can connect that, associate that with a custody transfer meter, and then the custody transfer meter can be associated with the other fitting and then go on down the transmission line, right? So instead of having just two lines connected together, I can put rules together of how these points are joined. I can actually have edge junction edge rules. So if I was to join, say, a transmission station piping together, do I have to require fitting in between, and what fittings are valid for that type of connection, right? So if you think of all the different types of pipes we have in that whole supply chain, how they get connected together is pretty important. And you can set up rules about how that happens in the geodatabase. Now we also have things we call containment rules. So I might, in my GIS today, just have a single point or polygon representing that pump station, but there's obviously a whole bunch of equipment that might be inside of it. This is really important when we start to integrate with things like Maximo and SAP. So I can open up that pump station and put other objects inside of it, and then use those associations, not only to associate the points together to the lines, but then gather all those things up and put them in a single object, like a point or a polygon, and then represent that at small scales. So as I'm on my mapping system, I see a simple point or a simple polygon for that pump station. As I click on open up, I get the more details that might sit inside of it. Then there's things like calculation rules. So as I attach a valve to a pipeline, that once that valve is connected, the attribute rule kicks off, and I can then say, hey, my valve ID is now a combination of my line ID and my valve ID together, right? So the editor, the data editing people don't have to remember to do that. It just happens automatically as a calculation as that is added to the data model. Or I might have some type of validation rule, right? So as I attach this valve to this pipeline, it looks at the rating value and say, hey, that's okay. But oh, no, you cannot connect that 50 PSI valve to that 100 PSI line. That's a constraint rule that you can build into the model. So again, looking at making sure we've got the cleanest data going into the model. Now, sometimes we don't know those values because depending on the order of operations. So here's a validation rule that, hey, I went ahead and connected that valve. I haven't filled out all the attributes yet. But once I do, it then runs a validation against those. And then if that fails, then it throws an error that is incorrect for that configuration. So constraint rules happen when the data has already been entered, or validation rules after they've gone in and changed or updated the attributes, rerun the validation and make sure those rules stay intact. So let's switch to another concept here, containment. So again, I mentioned, we have a lot of places along the pipeline where we have facilities, maybe it's a point or a polygon that has a whole bunch of details inside of it. These are really hard to manage at the GIS level. Things get really cluttered on the map. So here we can have almost a GIS within a GIS. So in this case, I've created a polygon that represents that pump station and then mapped out all the equipment inside of it. And it's all connected. So if I ran a network trace or went through the network, I'd be able to discover all that equipment inside of that. And along the pipeline, we have a whole bunch of places that's really been challenging in relational or linear referencing only world to represent these things. We've all sort of, how do we put in the pigging assembly and all its bypass piping and record all this information, or valve assemblies where we have pipes crossing over and connecting to each other. Do we create routes? Do we create measures here? We've had to sort of invent a lot of information just to represent this properly. With the utility network, I can simply draw those new pipes in. I don't necessarily have to have them linear reference. And then I can take the whole thing and put it in a container so that if I click on that small compressor site, I can see exactly what's inside that makes up that piece of equipment. And this is all contained within the data model. So there's nothing hidden or behind the scenes that you need to worry about. You can literally go into the feature classes once you've started creating these associations and see, hey, is this a container, or is it an attachment, or is it connected to another point feature? And you can see that in the data model, and you can report on that, and you can modify that. So everything's in the model that enables that functionality within the ArcGIS Pro tool. Now, kind of getting more deeper into the utility network and some of the advanced capabilities, there's two kind of major topics here. One is this terminal connections, and the other one is subnetworks I'll talk about. And a terminal is, the very way I explain this is that we've always had point devices in the model, but now we've given those devices intelligence of how they're connected to the pipes on either side. And in a generic sense, we call that a terminal in the utility network. So when I place an object, I then connect the terminals appropriately. Now, if it's a bidirectional valve, no drama, port 1 and port 2, it's pretty easy. But think of this as a pump or a meter or a compressor. It's going to have a low pressure in and potentially a high pressure out. And when I connect those devices that way, I then determine the flow. So no longer do I have to worry about the digitizing order or the way my stations are stationed on the pipeline. I simply connect my devices and I connect the terminals as a second operation, and that then determines how those are interacting with the pipes on either side. Now there's different types of terminals that you can configure. You've got pressure reducing, you've got generic flows, you've got bidirectional flows. We even allow you to model the CP current. So whether it's DC or AC mitigation, if it's CP in or AC out, we allow you to model that as well, which is pretty powerful in the system. So you can imagine this topic in itself can be very complicated. But again, the template that we delivered has a lot of this already baked in it as default. And once I set up those devices, once I've said, here's where my meters are, here's where my isolation valves are, here's where my pressure tier is, I can then ask the system, hey, build a hierarchy for me based on my equipment. So gone are the days where I have to go through every route and say system A, system A, system A, and remember to maintain that data. Everything that's connected to that pressure regulating device downstream of that until it gets to another one or a closed valve is going to be part of system A. And if I add another pipe, it automatically gets added to the hierarchy. So some really powerful tools to allow you to model and ask the question of the system, show me everything, show me the minimum and maximum MAOP of every device connected to that pressure system. Something we've been doing for years, but now it's kind of built into the tool set that allow us to run those types of calculations. Now, once I have the data in the model and it's connected, then I can really start leveraging some of the advanced capabilities of the utility network. And one of those is tracing, right? So when I start to trace the network, I'm basically asking, hey, navigate down all these pipes that I've connected together and start answering questions for me. Some of those questions might be, hey, show me all the pipes that are part of this isolation zone. If I have to turn, or if I have an incident here in the pipeline, where are the two nearest valves that I need to shut off? Or pressure zones. The example I gave is, show me the minimum and maximum MAOP of every device connected to this pressure zone. Or now I can even see the CP zones. So show me all the pipes that participate in this CP system. So in that case, an insulated flange would stop the CP, a closed flange would stop the pressure, right? So two different devices connecting in the way they're connected in the hierarchy would control how traces happen along that system. And you can build up all kinds of traces. There's actually trace functions that you can define. So as I walk down the pipeline and I discover all those connected devices, I could, for example, add a bunch of attributes together, like the inside diameter or the length, or maybe get the minimum and maximum value of some attribute of all the devices that I've discovered as I've walked down. So we have some basic trace functionality, but it's pretty limitless as far as what you can do. Once you build these traces, you can then save them. And then you can share them with web users, you can share them with mobile users, you can share them with other pro users. So these become very powerful functions that you can build once you have that connected set of pipes. And these are just some examples of some traces that you can do. You can do, by flow direction, downstream, upstream, sub networks. You can do traces with barriers. So you can put a barrier into the model and say, hey, don't go beyond this point, and then create all those attributes. The output of a trace is a selected selection set. So it's a selected set of features that then you can push into any of your other tools and do something with it. Now, the last bit of functionality that I want to cover are diagrams. And this is the old ArcGIS schematics, now moved over to Pro and included in the utility network. So if I have a connected set of pipes and I have a bunch of facilities, I can now create single line diagrams of that GIS data. Think of this as sort of the subway map, right? And so the output of a selection set, either manual or by a trace, can then be put into a diagram. The diagrams can then be symbolized, and the diagrams can then be saved and used in the portal. And the nice thing about these diagrams is they're bidirectional. So if I pick something on the map, I can see it in the diagram. If I select something in the diagram, I can zoom to it on the map. And if I query on an object in the diagram, I see all the PODS attributes, right? And as the maps get updated, the diagrams get updated. So instead of having a separate set of maps and diagrams to maintain in a third-party system, potentially causing two versions of the truth within the organization, we can now start building these diagrams off of that single source of truth. And those become just, a different representation of what we have in the GIS. And there's hundreds of templates that you can apply to how you want the layout to look. And you can also customize your own layouts, right? So there's, forest tree, there's diagrams, there's centroid moving out. You can pick and choose how you want these to look, and then apply those to your different systems within the model. So let me stop there for a second and move over to my ArcGIS Pro. So I want to give you a quick demonstration of this and what you would expect if you downloaded the model. So basically what we've provided to PODS is a PODS data model configured with all the rules and all those core features that we need in the model. Now, how this started was a working group within PODS. How it actually got built was through a project that was done with OneOak. OneOak wanted this capability. It wasn't quite ready from PODS yet. So they went ahead and built this model with Esri's help and then took the results of their work and donated it back to PODS. So this, in a sense, is already baked. It's already in production. It's a template to go starting from. What we don't have right now is a set of sample data. So I've just created some mock-up data here. But when you open the model, you'll start seeing those feature classes that I talked about. So if I open up the devices feature class, you'll see all the subtypes. So there's my compressor, there's my meters, there's my pumps, there's my valves, things that control the flow. Here's all my different assemblies. Those are my containers. Here's my junctions. These are how things are connected together. There you're seeing flange and closures and elbows and reducers and taps. And those are the core feature classes, along with this pipeline line feature class that has different types of pipelines. So transmission pipelines, gathering pipelines, stations, storage, and even some distribution piping here as well. Now, if you open up the ArcGIS catalog and look inside, what you're going to see is a featured data set called the utility network. And you can see all the relationship classes and all the code list domains that we normally have in PODS. But you'll now see in this utility network domain class, you'll see that I have an APR configuration in here. And if I scroll down, I have a utility network configuration. Those are the objects that you'll see in the enterprise geodatabase that contain all the rules and configuration. But everything else is lines, points, and polygons. So here's my miscellaneous fittings, here's my markers, here's my pipeline lines. And basically what I've done is just go ahead and add those to the map and symbolize them. And I basically went up to the the Esri website and grabbed our symbol set and added it to my project and just borrowed all those great symbols that Esri's been developing and used it with my PODS data, no problem. So how do I build one of these things out? Well, what I did is I just went to a source location in my system where I had some legacy data from another data model, right? So I have some transmission lines and I have a couple of gathering lines here. And those are sitting out in a legacy PODS model. And I just brought them into my map just so I could have access to them. And to get started, what I did is I simply used the copy and paste method inside of Pro. So I grabbed a small section of these pipelines and I copied them and I pasted them into the pipeline line feature class. Now in this example, I didn't worry about all the detailed data modeling of all the attributes. I really was just focusing on what type of pipe it was, which is the asset group, in this case, transmission pipe, and the asset type. In this case, it's a main line. And if I pull this down, you can see we've got crossovers, loops, lines, and laterals, right? Remember I was telling you asset group and asset type are the most important thing here. So you can see I've got 7 transmission lines and I've got 8 gathering pipelines. And if I select only my gathering pipes, I'll see those on the map as well. Let me just clear that. Now, when I first started this, not a lot of interesting things, probably what you'll see in your GIS today, kind of overlaid 2 systems. Maybe they're connected, maybe they're not. First thing I do is I do a simple trace to see what I came up with. Now, one of the other things I'm going to show you here is this, what we call this unified pipeline toolbar. So historically, you had to continue to switch between the utility network toolbar and the APR toolbar to get things done. Well, what we did was we built you a unified toolbar that has both linear referencing and utility network all in one place. Users aren't having to click around all the time. So I'm going to be focusing on using this toolbar. If you're interested in this toolbar, reach out to me. It's on our GitHub repository. It's a simple download and adding to your Pro project. What I'm going to do now is a simple connected trace. So when I do a trace on this, I first just have to define a starting point. So let me just grab the endpoint of this line here, and I'll put it just right on top of one of these gathering lines. You'll see there's 4 of them coming into that yard there. And I'm just going to run one of my named traces, which is just a connected trace. So this is run out, and it's just taken the geometry that I had from my existing GIS and see what was connected together. And it did pretty good. It got pretty far up the system. You can see I don't have a connection here. I've got a couple other lines that aren't connected, but it did explore all the way out to the end of this line. So let's take a look at some of these potential connectivity issues. So I see this line coming in first. It's not connected. If I zoom closer in, typical GIS data, right? I've got this line, it kind of ends short. I'm not exactly sure which of these lines it connects to, but if I did a little research, I'd find out that this actually is a T coming off this line. Maybe that's in another document that I have access to, or maybe it's in my other legacy GIS data. Maybe it's a point event. But if I want to connect these lines together, well, the first thing I'm going to do is I'm going to use my tools and I'm going to create a T. And I'll just pick on that T and I'll come over and for some reason it's not snapping to this pipeline. I'm not quite sure why. Well, it's because I have a rule that says a T has a type associated with it, and a 3-way T has a rule that it can be put on a gathering pipeline. So as soon as I select that asset type, the rules kick into place, and the rules are actually overriding my normal snapping routine in OnPro. So I can snap that to a vertex inside of my utility network. Maybe I create a connection point on this other pipeline here. Let's say it's a pipeline connector, because I don't want to just draw a piece of pipe that I don't know about. But now using the utility network tools and that association functionality, I can go ahead and modify that connection point and connect it by a junction to that T. Once I apply that and validate it, I can look at my connected view here. I can see that that's now associated with that other pipeline. And now if I go back and run that trace again, you can see it's now going to discover that T. It's going to hop across to that connection point, and it's going to take on off the line and go down. Now, maybe I don't have, I don't know exactly what's there, but I can see there's a geometry error. Well, this all works with the out-of-the-box tools as well. So let me just clear this, the selection set here. And let me just go back to my normal editing ribbon, right? So this is the power of using ArcGIS Pro. If it's not on my APR toolbar, no drama. I can just go back and use some of my core tools. Like here, I'm just going to go ahead and do an extend. I'm going to select this pipe to extend. And if I use the extend option, I hover over this pipeline, you can see it gives me a little preview. It's going to extend it right into that gathering line. Now you can see this kind of blue area. What that blue area means is that I've actually connected these pipes, but I haven't validated that that is a valid connection. And so in the utility network, we have this idea of what we call a dirty area. And a dirty area just shows me where my data hasn't been validated yet. So although I've connected these two pipelines together, maybe there's a rule that says that's invalid. So I'll go back to my toolbar, I'll hit validate, it'll run my rules again, it'll clear that dirty area, it'll say it's successful. And again, if I go back in and run that connected trace again, you can see I've now picked up that line. And we can go on and on. We can start building out this site, you know, placing valves and meters and compressors in here, connecting it to my main line. But you can see there's a number of ways to clean up the network to end up with a connected set of pipes. And at this point, you can see there are no route measures, right? I can put route measures on this blue line, but if I don't have route measure information on my gathering lines, no problem. I can just keep them just as pipe features in the utility network and move my way forward. And eventually work this up so I can create a connected diagram of that whole facility and see that in an alternative view. You can see in my diagram, I have all kinds of things like my devices, my pipelines. I can symbolize this view, but this ends up becoming an alternate view of that network.
Jeff.
So I know we've got a couple of minutes left, so I wanted to open it up maybe to some questions.
Yeah, so my first question is, man, how did you extend that pipeline so quickly without getting a permit?
Hey, I'm just the editor. I don't do the hard work.
Yeah, if we could figure that out, right? Is that under Nationwide 13? What do you use there? Is it individual permit? How long did it take you to get that?
That's why I went to PPIM last week and I realized I need to stay in my lane. This is what I do. This is my lane.
Yeah, and it's a great lane to be in, that's for sure. Because you know the up and downs of you know the imperceptibility of the permitting world. Geez, if we could figure that out. So we do have a question that came through. Do UN rules apply to events as well?
No, they don't. But the events themselves, so utility, the APR has its own set of rules around what events can be connected to what other events, and you can use calculation rules. Some of those rules that I showed you on the PowerPoint slide are actually just done in arcade scripting right to the core Pro. So those can also be extended to APR objects as well. So,
Okay.
but no, the rule base itself, the utility network, is really about those features that we have in the UN.
Okay, so I know we're at time right now, so I do want to say thank you so much, Jeff, for giving us all this great information. And we're going to have this up on our YouTube site and on the website. And I just want to make sure everybody knows too, at the spring forum, we have a lot of discussions and breakout sessions this year. So like, we're going to be like a real event, like a real forum, a real conference. So some of the topics are going to be like road mapping to PODS 7 and, bulk data loading and, and we're going to have one room specifically for working sessions with whiteboards, and people can, nerd out and whiteboard out a bunch of stuff. So please join us for that. Any of the other questions that you have, you bring those there. I'll get those to Jeff too. And thank you again, Jeff, for this. And thank you to
Of
Esri
course.
for all you guys do. We really appreciate it. And if we don't see you any sooner, we'll see you in April in
In
Houston.
Houston, yeah. And there'll be a number of technical sessions and user paper stories, success stories about APR and utility network as well. So keep an eye on the detailed agenda. It should be up this week or early next. And anybody has any questions, that demo just scraped the surface. Sarah does a much more deeper dive, and we're available to jump on a call with anybody who wants to see more about what we have. But that pro project that I work on is the one that Monique has. That's up on the PODS website. You can download that today and start kicking the tires.
That's awesome. I'm excited. Sarah's going to join us for the Women in GIS Pipeline panel too. That's going to be so much fun.
She is as well. Yep.
Awesome. Thank you
Cool.
again, Jeff. Appreciate it.
Awesome. Thank you very much.
See you soon.
Bye.